One of your homework problems asks you to verify that points lie on the graph of an equation. And so what I've done is I've created a similar problem to help you understand your assigned problem. Here we have a curve y equals x cubed minus 3 square root of x. And the 3 points that we're trying to determine, if these points lie on the curve, have the coordinates that are given. What we want to do is substitute the x and the y value of the given coordinates into the equation. Then use computation and simplify the right-hand side of this equation. And we get a statement, 0 equals 0. Now that is a true statement. So whenever we end up with a true statement, the point we were considering, in fact, lies on the curve. So we can state that with confidence. The next point, 1, negative 2. Does it lie on the curve y equals x cubed minus 3 square root of x? We will substitute y for negative 2 and x for 1 into the equation. We will simplify the right-hand side and now combine. And because it's a true statement, this point, 1, negative 2, does lie on the curve. The last point, 1, negative 1. Well, we notice it has the same x coordinate as the previous point, so we're kind of hoping that this would not lie on the curve. If it did, it would not be a function. You will recall from Algebra 1. We are going to substitute our x and our y. Now we're going to just simplify, and we get a false statement. So 1, negative 1 does not lie on the given curve. So we have done that without graph paper, without a graphing calculator. We've done it simply by substituting the x and the y coordinates into the original equation and seeing if the resulting statement is true or false. Now we could definitely use a graphing calculator or a graphing utility like Desmos.com. We could type in the function y equals x cubed minus 3 root x, and we would get a curve that looks like this. Interesting that there are no negative x's allowed because you cannot take, at least in the real coordinate system, the square root of a negative. Now, looking back at our original points, 0, 0, we can see that does lie on the curve. 1, negative 2 does lie on the curve, as we had proven in the previous slide, and 1, negative 1 does not lie on the curve.